At Hexagon, we're using Hoops Visualize and Hoops Exchange in Inspire. This is a newer product we have released recently, relatively recently. And our area of use is metrology, which is measurement. So we would say you can't build what you want unless you know what you've built, right? So you've built this part. This is a sample part we're going to be discussing, and we need to be able to measure it. So one of the areas we can do, we can provide analysis is cross-section analysis. And this allows our customers that when they inspect parts, you could take a CAD model, you can scan it, and you can slice the part with these planes. And then you can do the analysis on the individual planes, right? So what the setup we're going to have here today in the demo is I've got an arm, I've got a 7-axis hexagon arm here, and I'm going to be using this to take measurements of the part, which is on the table next to me. We're going to align to the part, we're going to do some probing to align, we're going to scan, and we're going to do analysis and cross-section analysis. And then I'll go through and show some of the code side of it too. So there's two modes of measurement we're going to use. I'll go over this quickly and then we'll get out of the PowerPoint. There's probing and there's scanning. Probing, you'll see I'm going to start with probing, and that's where I'm taking the arm and I'm touching points on the part. It's a physical contact measurement. And you see this probe is a sphere. And so we touch on the part, we get a measurement, we get the center of the sphere. We know the radius of the sphere, so we can offset and figure out the actual measurement, the surface measurement. So we'll do that first. The other mode is scanning. Scanning, there's no contact, no physical contact with the part, just using it's an optical measurement. And so we're going to go across the part, and we're going to scan a point cloud. All right, so let me, I'm going to present here. I'm going to have the Inspire running on the one side and a second camera showing the part, so you can kind of see them both at the same time. Okay, so you see I got the live camera view of the part, and I've got Inspire. Close that. All right, so the first thing I'm going to do is bring this down. So we've got the instrument, so I'm going to add the instrument to the job. And one of the things in Inspire is we support many different instruments from different manufacturers. So whatever instrument you have, you can pick it. And we have abstracted the differences between the instruments so that we can talk to them all in the same manner. So we don't, regardless of what instrument you want to use, chances are we support it. So we're going to add the instrument, and I'm going to connect to it now. Okay, so we're connected. Now, if you look at that, you can see, I'm going to go over here and take the instrument out. You can see how the 3D model updates in real time. So we're tracking with the instrument and we're seeing the updates. Okay. So the next thing I'm going to do is import a CAD model. This is the CAD model that represents the part that we're going to measure. So we drag that in, we've got the CAD model, and you can see it's the same thing. This is the same model. And I'm going to go ahead and start taking some measurements. So I'll take the arm out. It's in probing mode now. And you can see I'm going to measure the cylinder on the top. So I'm going to go in here, I'm going to start taking measurements. As I take measurements, Inspire will see, oh, you're trying to measure something. And as the measurements come in, it's going to try to determine what the feature is. As I go more and more, it's going to say, oh, you're measuring a cylinder. So it's identified as a cylinder, and I was able to measure that feature. Now what you'll notice though is the cylinder I measured is way over here. The cylinder is nowhere near the CAD model, and that's because the instrument measures relative to itself. Well, we haven't told Inspire where the instrument is relative to the CAD model in the real world. So the first thing we always want to do is align. We want to do an alignment. So Inspire has a number of alignments here, and we're going to do frame alignment. Frame alignment is where we will pick 3 features on the model, and it'll form a coordinate frame from that. We'll then go measure those 3 features. It'll bring the 2 together and we'll be aligned. So I'm going to start a frame alignment here. Frame alignment, and I'm going to pick the feature. I'm going to do the top plane, do the side plane, do the front plane. And now it's telling me to go measure these. Okay. So we're going to measure. Again, bring the arm out. I'm going to take points on the top to measure the top plane. Got 6 points there. I'm going to advance the arm to the next feature. Extra points on the plane here. that was back to my phone, which is the front plane here. Now that we've done that, we're aligned. Now you can see, now that it's aligned the model to the part, as I move the model, the arm, it matches what you see in the 3D graphics. And also you can see our cylinder, the cylinder that we measured is now showing up correctly on the part. We'll hide these. So now we've got that cylinder correctly placed. Now that we're aligned, the software knows how the instrument relates to the model in the real world. Now we can actually take measurements and compare them to the model. So let's do some scanning. Now that we've aligned the model, we'll scan. And to do that, I simply pick up the arm again. I switch to scanning mode. There's a switch in the back. Now we're in scanning mode, and I'm going to see if I can. Now while we scan, we have a tone that gets generated. A higher pitch is good, a lower pitch is bad. You want to be measuring perpendicular to the part, just the right distance, so it gets everything. So you can hear the tone go up and down, and hopefully I'll get some good scanning here. Data coming onto the part as I'm measuring it. Not happy with that. So I got the top there. We'll scan the back here. Having heart to this. And we'll scan the front. All right, so now we've scanned our part. And what that's produced is a point cloud. And if I go to the properties, I can see that was 1.7 million points we just scanned in. Now, when we scan the point cloud in, we voxelize it. We basically create a volume of cubes, and for each cube, get a representative point. We simplify it that way. So we go from 1.7 million down to 66,000 in this case. We can adjust the voxel size if we want, and we render the voxel cloud. I can click here and render the raw cloud, and you see now we're rendering all 1.7 million points. And of course, visualize doesn't even hesitate. I mean, that's 1.7 million points doesn't even hesitate. We have completely fluid frame rates and everything. We'll go back to voxel. So now we have the scan data, and what we want to do is we want to go back to we're going to do the cross-section analysis. So we want to slice the part with planes, and each plane we want to compare the cloud data at that plane to the model. So I'm going to hide the cloud for now, just so you can see the planes better. And we're going to extract a plane, a representative plane from the model. So we have the ability to extract geometry from CAD. So I can extract circles, cylinders, planes, etc. I'm going to extract a plane from this back part of the model here. So I've got the plane, I've got the cloud. I'm going to go to our analysis tab. I'm going to say create a cross-section analysis. Okay, so I've got to select the nominal. The CAD model is the nominal. The cloud is what I scanned, and then here's my reference plane. Okay, so now what I need to do now is create a series of planes to cut the model. So I can go into here, I can make offset copies. I'm going to reverse the direction of the offset, and I'm going to increase that. So now you can see that we have a series of those cross sections. And ignore the size of the planes, just consider them infinite planes. And what happens is we analyze it. I'm increasing the magnification there. And you can see that along each plane, we've gone to exchange. Basically, in exchange, we give exchange a plane and a model, and it cuts through it and it makes a series of intersect curves. Along those intersect curves, we project the cloud data in that neighboring region, and we get the errors. So you can see on each of these sections, the whiskers or the errors are color-coded, showing you in and out of tolerance. And but we can also look at individual sections in 2D. So if I go into here and I double-click one of these sections, I can now view the individual section in 2D. So as I step through the sections in the model, I can pick a particular section for analysis and take a look at the errors. I can mouse over these and I get the individual error values. Another feature is another thing you can extract these intersect curves. These are generated again by the intersection of the plane and the model, and we can extract geometry from that. So I can click on that. I can extract a line, extract a circle, and I can get geometry from those intersect curves to be used for other purposes. So that's the demo, and that gives us the cross section. Let me go back to the PowerPoint. We did the alignment, we did the scanning, cross-section analysis. All right, so here's the more code side of it. As I said, we take a CAD model and a plane and we intersect the two. Exchange has an API, compute planar sectional model file. We give it that information and it comes back with a set of representative items. The rep items have curves in them, which could be composite or individual, and we pull that data out. And here's some code. In the code, you can see we call the compute section. We loop through all the rep items. We pull out the curve rep items. For each of those curve rep items, we got to say, okay, is it a composite? Pull out the curves, the regular curve. At the end of all this, we end up with these curves. We then find the cloud data in that neighboring region, and we project the cloud data to the curves. So to do that, we say for all the points in that region, for all the curves, we project the point to the curve. And Exchange lets us project a point to a curve and gives us back curve parameters. We then evaluate those to get the X, Y, Z. And we say, what is the closest solution on a curve? And of all three of these, which curve is the closest? That's our closest point. And so that would be the error value. That would be used to generate the whisker for this particular location. So on the code side of it, you can see we're going through the curves. We're projecting to the curve. And we're finding the closest one. The last thing was the extracting geometry. So extracting geometry from CAD, this is from the intersect curves. Given this set of intersect curves, Exchange has another cool feature that lets you, given a curve in CAD, an edge curve, simplify with analytics. So we say simplify curve with analytics, and Exchange will come back and tell us, oh, that's a circle, or that's a line, or that's, And the other kind of cool thing about Exchange is it'll say, oh, this was actually saved as a circle in the CAD, versus it was saved as an already circle means it was actually saved as a circle in the CAD. However, even if it wasn't saved as a circle, Exchange is still smart enough to say, well, let's look at it. It really looks like a circle. So it really is a circle. So that opens up a lot wider set of geometry, and you're not dependent on the CAD model actually saving it as a circle, right? So to do this, we simplify curve with analytics, and then we have additional code not shown here. But okay, if it's a circle, go pull out the circle geometry. One of the interesting implementation challenges was when I showed you extracting geometry from the model, that demonstrates, when I was making that reference plane, that demonstrates a really nice integration between Visualize and Exchange. When you're in Visualize and rendering with Visualize, you can mouse around a CAD model, click on something, and the mapping the whole way back to Exchange is maintained. So I can click on an edge, it will give me a path into the CAD model. I can go to Exchange with that path, and I can then do the extraction. This was a little different because in this case, we're asking Exchange to give us a series of intersect curves. Well, these intersect curves are not in the model, these are just created on the fly. So we weren't sure how are we going to, from graphics, go back to these intersect curves because there is no mapping. So what we ended up doing was, at the time you create the intersect curves, we go through and extract all the geometry right away and hold on to it. So we kind of solved it by doing that. And so then all the geometry is there. And if the user wants it and they mouse over it, they get it. So that's the demo. Any questions?
Yeah, thanks. Thanks, Dave. That was great. It's great to see in real life something, real workflow. And it's exciting to see the modeling kernel behind that is Hoops Exchange. So a lot of your math is being handled by Hoops Exchange, isn't it?
Yeah, it is. We in Inspire, we import with Exchange. We hold on to that PRC data, render it with Visualize, and then things like point projection, this cross-section analysis. We rely on Exchange for all of that currently.
Yeah, great.
Yep,
Oh,
it's worked very well. The plane intersection one, we had this requirement come up to do this, and I said, well, I guess I could ask TechSoft and see if they could add that for us. And it was like, oh, we already have that. So we wired it up and it worked. So it was great.